Hello everyone, in this video I am going to discuss the problems on acidity and basicity, and these are the previous year's questions of JAM and GATE. Here we have the first question, the correct statement is or are. That means more than one answer can be correct. The first statement is saying that pKa1 of C-cyclohexane 1,3-diol. So C-cyclohexane 1,3-diol, it is basically one OH will be above the plane, another OH will be, both will be on the same side. And if we consider the trans, so here you can see we have total 2 OH group. So that is why the question of pKa1 and pKa2 arises. But we have to consider only pKa1. But if we draw this type of structure, it will be, it is not possible to answer the question. So what we will do, we will convert it to chair form. So when it is chair form and 1,3 position and it is cis, that means both OH group, either you have to place them as axial or equatorial. But here we will do it as axial. What is the reason behind that? Because if you do so, then only you can draw the hydrogen bond that is possible in the conjugate base. So the conjugate base, after removal of one hydrogen, it will be something like this, O negative, and there is hydrogen bonding possible. So that is why axial is drawn. Now this type of interaction is not possible in case of the trans isomer. Why? Because here one OH you have to place as axial and another OH that you have to place as equatorial. So that is why here this type of stability factor is not possible, but here it is possible. So that is why here acidity of cis is higher than that of trans. And if acidity is higher, that means pKa1 that will be lower. But here it is mentioned is greater, that means this statement cannot be correct. Next statement, that is B, it is related to trans 4-tertiary butyl cyclohexylamine. Now again we will draw the chair form, and 1 and 4 position we have two groups, and whenever there is tertiary butyl group, you always have to place it as equatorial because this is large group. Now when it is 1 and 4 and it is trans, that means both of them will be either equatorial or both of them will be axial. Now this tertiary butyl group, obviously it is equatorial, so NH2 group that will also be equatorial. And what about the cis form? Now in cis at 1,4 it will be axial equatorial or equatorial axial, but tertiary butyl group that is fixed at equatorial always. So it is EE for the trans but EA for the cis. Now for cis, here after showing basicity, when NH2 group will be converted to NH3 plus, now it is becoming larger group, and when it is becoming larger group, there will be interaction at 1 and 3 position in case of cis. So what will happen here, if you consider these two hydrogen and 3 position, there will be steric repulsion. That means this conjugate base that we are getting from cis, that is not stable. So basicity will be higher in case of trans. This is the order, that means this statement is correct. Now number C, 2,6-dihydroxybenzoic acid and salicylic acid. So both are having CO2H group connected in benzene ring, but in the first case we have 2 OH group at ortho position. In case of salicylic acid, we have only one OH. Now if we consider its conjugate base form directly, the conjugate base that you get from 2,6-dihydroxybenzoic acid, which is basically the benzoate anion, this O negative, you can see here both sides there is some stability possible. Okay, both sides there we have some 6-membered ring formation, and that is giving its conjugate base stability. But when it is salicylate ion, that is the conjugate base that you are getting from salicylic acid, that is comparatively less stable because here we have only one 6-membered ring. So that is the reason this one, that is the first acid, will be more acidic, and this statement is also correct. What about the last one? Now if we actually consider the answer key of JAM 2023, it is mentioned in the answer key that either B or C or B, C, D. That means D, even that is, it is correct and also it is not correct. But what is happening here? if we consider the experimental value of 2,4,6-trinitrophenol, which is nothing but picric acid, and 2,4,6-trinitro-benzoic acid. So here also we have 3 NO2 substitution, just like the first one, but instead of OH, now we have CO2H group. That is the difference. So pK, if we consider, then obviously this statement, it is lower pK, so this is more acidic. That means D is also correct. And this is the experimental observation, but if we actually see the molecule here, O negative, that we are getting from the first acid, and here this NO2 group, it can show minus R effect at ortho and para position. So that is why this is also very stable. But what about the CO2H group? In place of O minus, when you have, that is OH, when you have CO2H group, we know because of steric inhibition of resonance, whenever there is ortho substitution in benzoic acid, there is increase in acidity. So because of that factor, this acid is also, that is trinitro 2,4,6-trinitro benzoic acid is also acidic. But there is slight difference between their pK value. So that is why 2,4,6-trinitrophenol, that will be more acidic. Fine. So even if we do not consider it, then also it is correct according to the answer key. But after all, just based on the experimental observation, this is also correct. So B, C, D, all these 3 will be correct. Here we have again more than one answer may be correct. It is related to malonic acid and acetic acid. If you read all the statements, in all the statements there is mention of malonic acid and acetic acid. So first pK of malonic acid lower than pK of acetic acid. So we have to know what is the structure of malonic acid. Otherwise how we will solve. So for malonic acid there is 2 CO2H group. But in case of acetic acid there is only 1 CO2H group. So that is why the question of pKa1 and pKa2 arises in case of malonic acid. But for acetic acid it is only 1 pK value that is possible. Now for acetic acid, if we consider the experimental value, though we will also see what is the actual explanation, 4.76, that is the value. In case of malonic acid, if you consider pK, that is the first pK, that is actually 2.83 and the second one is 5.69. So experimental value is saying that first statement should be correct. First pK of malonic acid lower and second pK, that is higher. 5.69 is greater than 4.76. But what is the reason behind that? To understand the reason, we will draw the conjugate base. Here O negative, that is I am drawing it for malonic acid, OH, C double bond 2. Now this type of hydrogen bond is possible, which is giving it some stability. So that is why when the first hydrogen will be lost, we are getting this type of conjugate base. And that is why it is more acidic than acetic acid. Though in acetic acid there is some resonance effect possible, and that resonance effect is also applicable here. But this is something that you cannot have in acetic acid. So that is why the first pK is lower, that is more acidic. But when it is second pK, now this hydrogen is already, it is part of this hydrogen bonding. So removal of this hydrogen is not easy. So that is why pK2, now it is lower than the previous one. So here option A will be the correct option. Increasing order of acidity of the given molecules, we have total 4 molecules. Here we will focus on this molecule first, because see, it is CO2H, and when it is carboxylic acid, obviously its acidity will be high. And also there is some fluorine substitute. That means it will be even, acidity will be even increased. So 3 will be maximum acidic. But that will not help us to choose the option, because in all the options you have 3 at first position. Now what to do? The next one you have to move. The next one is basically this OH group. Because if you look at the other 2 molecules, here also we have OH group. So you can compare 1 and 4. So from 4 you will get CH3O minus, but from phenol you will get PHO minus, and this negative charge is stable because of resonance. So that is why 1 will be more acidic. After 3 it will be 1. So you can cancel these 2 options, but you are stuck between C and D. So after 1, what you will do? You have to compare to acetone and methanol. But in acetone, when you remove hydrogen, you are basically getting negative charge over carbon. But here negative charge is over oxygen, so that will be more acidic. So after 1 it will be 4, and that is why option C is the correct option. Now this is comparatively easier. The compound that contains most acidic hydrogen. See here, the hydrogen when we remove, we are getting some negative charge over carbon. So this is sp2, here it is sp, this is CH2, this is again sp2, and here it is sp3. So obviously here negative charge will be maximum stable, and that is why this is the correct answer. Correct order of pKa of the following compounds. Now order of pKa means first we will see what is the acidity order, then pKa will be the reverse. Here we have OH group in first and second compound, CO2H group in third and fourth. Now obviously carboxylic acid you have to give more priority. Now between 3 and 4, when there will be negative charge generation, resonance is possible in both cases. But here we have this extra electron withdrawing group NO2, and because of its minus R effect, there will be positive charge generation at this carbon, which will even increase the acidity of this hydrogen. So 3 will be maximum acidic, right? After 3 it will be 4. Now what about the 2 OH group? Now in these two we have NMe2 in case of second, which is having some donating effect. So that is why 1 will be more acidic. So we will write 1 and then it is 2. So 3, 4, 1, 2. So you have to reverse it, right? So reversing it we are getting, that is, just see the signs are now reversed. Now 2, 1, 4, 3. So option B is the correct option. Correct order of pKa value for the conjugate acid of the following heterocyclic compounds. So it is not directly asking the basicity, it is asking the pKa value of the conjugate acid. So simply what we will do for all these 4 molecules, suppose I am writing it in general as if it is B, that is base, and in presence of some H plus it is becoming the conjugate acid, which is BH plus. So this is the conjugate acid, right? Now you have to consider these factors. When basicity of B is very high, that means the capacity to capture H plus is high, and that is possible because BH conjugate acid, its stability is very high. So when basicity of B is high, stability of BH plus is very high. That means when basicity is increasing, stability of BH plus is increasing, and acidity of BH plus is also decreasing, because when stability is high, obviously reactivity is less, right? So acidity will decrease, and when acidity is decreasing, that means pKa is increasing. Now consider these two are that is same way it is, or that is its change is in the same similar way. So basicity of B is increasing means pKa of its conjugate base is also increasing. So though the question is asking the pKa value order, simply consider the basicity order, because basicity order and the pKa of conjugate acid order is same because of this logic. Now maximum basicity you can expect in which case? Now in this two, here the lone pair, it is present in sp2. It is also in sp2 in case of 1, because there is some resonance going on. So 1 and 4 in these two cases, the probability of getting the, that is the lone pair availability, is comparatively less. Now among 2 and 3 will be more basic, okay? That is the lone pair availability. You can also consider as if here 2, that is 2 extra CH2 group is there, so even it is increasing the basicity. So after 3 it will be 2. Now after 3 it is 2, that is basicity. Now among 1 and 4, in case of 4, the lone pair availability is higher compared to pyrrole, that is the first one. Why? Because it is not participating in resonance. But in case of the first molecule pyrrole, because of stability and also to attain the aromaticity, that is total 6 pi electron, now this lone pair will not be available. So that is why its basicity will be least. So 3, 2, then 4 and 1, that is option C. And that is also same as the pKa value of conjugate acids order. Least acidic among the following compounds. Now this is also comparatively easy, because least acidic means you have to remove the hydrogen and just check whether the negative charge is stable or not. Here if you remove this hydrogen, you are getting negative charge over carbon. But in all other cases, you are getting negative charge over oxygen, isn't it? So obviously from NOP, the conjugate bases that you are getting, they will be more stable than M. So least acidic will be the first compound, M. Increasing order of basicity among the following is. If you look at these three molecules, this part is common, isn't it? It is present, that is this NME2 group, its presence, that is its positions are same in all this. Now what is the other factors that is making the difference that we have to focus on? Here we have OCH3 group at the para position, and this is having some donating effect. But you can say the OCH3 group is also present here, that also plays some donating effect. So X should be, that is the first compound should be least basic. But what happens in case of Y, when it will, this lone pair, that is to show the basicity, when there is less steric inhibition, it is better. So after that is, suppose it has already captured some H, now this is NH plus, it will be even larger and there will be steric problem with OCH3 group because they are at ortho position. So just because of this steric reason, capturing H plus it will be difficult. So that is why ultimately Y will be minimum basic. And among X and Z, obviously because of presence of OCH2 group at 4 position with respect to NME2 group, it will show more basicity. So Z first, X and then Y. Option A. Correct order of basicity. So this is directly asking the basicity. And here, see, the first three molecules, the lone pair availability, if we check, it is lesser compared to 4 because only in case of 4 it is not, that is the lone pair is available compared to the other 3. This is in sp3 hybrid orbital. In case of pyridine it is in sp2. So among compare 3 and 4, so 4 will be maximum basic. Now after 4, in case of 1, 2 and 3, in all these cases it is in sp2. But remember in case of 3, it is not part of any conjugation. So that is why lone pair availability is high. So after 4, the next one should be 3. Now 4, 3 fine, that you can get in 2 options. So still we have to work. Among 1 and 2, in case of pyrrole, it is obviously taking part, it is achieving aromaticity. But see, in case of indole, the same thing is possible, but here we have this extra benzene ring. So the conjugation is now even more extended. And that is why the lone pair availability, if we compare between 1 and 2, it is even lesser in case of 2, that is compared to 1. Because we have extra benzene ring, more delocalization, more is the chance that is lone pair availability even decrease. So that is why after 3, the next basicity among 1 and 2, 1 will be high and then 2. So it is matching with C. Okay. So that's all in this video. If you find it helpful, please like, share and subscribe. Thank you for your time.